Yes, good afternoon, students. The class has been started. So, today the topic to be discussed is environmental refrigerants, designation of refrigerants, nomenclature of refrigerants, and applications of refrigerants. We'll discuss in this class, right? So, in the last class, we have discussed about the classification and some of the engineering environment applications. So, today in this class, we'll discuss about the designation of refrigerants, how they are designed. 1 second, you are having some screen problem. Okay, see here. So we are calling the refrigerants by the name R. Capital R resembles refrigerants, and the numbers 11, 12, 14, 21, 22, these are all the numbers which are referred to the chemical formula thing. The refrigerants are internationally designated as capital R, and you are having some of the numbers. A refrigerant followed by two-digit number indicates that the refrigerant is derived from methane base, while three-digit number represents ethane base. So what it is saying here? So రెండు నెంబర్లు ఉన్నాయి అనుకోండి, it is methane based, right? Three numbers ఉంటే that is ethane based, right? So two numbers says that it is a methane. So when 11, 12 methane based, 114, 116 like this, that is ethane based. The numbers assigned to hydrocarbon and halocarbon refrigerant have a special meaning. The first digit on the right is the number of fluorine atoms in the refrigerant. The second digit from the right is one more than the number of hydrogen atoms present. The third digit from the right is one less than the number of carbon C, but the digit is zero. The general chemical formula for a refrigerant, either for methane or ethane base, methane or ethane base can be given as CHClF. So what is the meaning of this one? E is given as, which is what is meant by small m, small n, small p, and small q. So this gives small m is equals to, so see here, it can be given as CM, HN, CLPFQ, which NPQ is equals to 2m plus 2. N plus P plus Q is equals to 2m plus 2. M is equals to number of carbon atoms. N is equals to number of hydrogen atoms. Small p is equals to number of chlorine atoms. Small q is equals to number of fluorine atoms. So the number of refrigerant is given by capital R, m minus 1 of n plus 1 small q. Let us consider the following refrigerants to find the chemical formula on the number. Now see here, just an example how the refrigerants can be designated. Okay, how the refrigerant can be designated. See here, for example, if you take difluoromethane, we see that in this refrigerant, the number of chlorine atoms is P is equals to 2. Number of chlorine atoms P is equals to 2. Number of fluorine atoms Q is equals to 2. And the number of hydrogen atoms small n is equal to 0. So that n plus Q plus n is equals to 2 of 2m plus 2, right? So here n plus p plus q is equals to 2m plus 2, that is equals to n is equal to 0, p is equal to 2, q is equal to 2. That implies 2m plus 2. Therefore 4 is equals to 4m plus 2, that is equals to 2 is equals to 2m, so m is equals to 1 finally. Therefore the number of carbon atoms is equal to 1. Therefore the chemical formula for dichloromethane becomes CCl2F2, and the number of refrigerant becomes R of 1 minus 1, 0 plus 1, 2, or R012, that is R12. So like this we can designate, the number of the refrigerant. Then what is the meaning of R12? R12 is dichloromethane. So here 2 digits unnai ankondi, that is methane based. 3 digits unte, that is ethane based. Now ikkada R12 undi kabatti that is a methane based. Next how to design, how to designate, right? Next, environmental refrigerants. Environmental and safety precautions regarding to the refrigerants we will discuss the next topic. So here the ozone depletion potential, that is ODP. The ODP refrigerant should be 0. That is, they should be non-ozone depletion substances. So what it is saying, it should be a non-depletion substances. Since the ozone depletion potential depends mainly on the presence of chlorine, okay na? The ODP depends mainly on the presence of chlorine or bromine in the molecules. Refrigerants having either chlorine and CFC based and HCFC based or bromine can't be used under the new regulations. So what it is saying, ozone depletion potential, the ozone depletion potential is the refrigerant should be 0. The refrigerant should be 0 here. So if the refrigerant should be 0, then what happens? Depends upon the presence of chlorine or bromine molecules. Okay, so that's why the ozone depletion potential should be kept 0. Next, global warming potential. Next one is global warming potential, that is GWP. The refrigerant should have as low a GWP value as possible to minimize the problem of global warming, right? So generally the refrigerants are chemicals which are used in the refrigeration. So we are using various types of chemicals what we have discussed, that is R12, R14, RCC12, like that. No? So in order to protect the environment, from refrigerants, so they have been prescribed some laws, environmental laws. So what is the law that they are said? Global warming potential. The refrigerants have as low as the value of GWP to minimize the problem of global warming. That's the meaning. Okay, na? Next, total equivalent warming index, that is TEVI. Total equivalent warming index. Total equivalent warming index. Here, the refrigerants with as low a value of TV are preferable from global warming point of view. So, manakunna all environmental and safety precaution points, the refrigerants, they are saying that majority will be as low as possible, right? So, for example, if you see our cell phone towers, if you see our cell phone radiation signals, Airtel, Geo, Airtel, your V, whatever it is. So if you see, the frequency should be maintained normal. So if you are keeping high frequency, what happens? So we can get good audible, but our ears, sensitive ears, will get damaged, right? And also the sparrows, small birds which are in the sky will get hurt. Small flies, small birds will get death. So that is a concept. They will say we have to maintain as low as the concerned government said value. So in the same way, the refrigerants also, the global warming should be kept low, the total equivalent warming index should be kept low, and toxicity, the refrigerants used in the refrigeration system should be non-toxic. Okay, the refrigerants, what the refrigerants, either inorganic refrigerants or organic refrigerants, right? The refrigerants used in the refrigeration system should be non-toxic గా ఉండాలి. Some refrigerants such as CFCs and HCFCs are non-toxic when mixed with air in the normal condition, right? So that's why initially the refrigerant should be of non-toxic in nature. Next, flammability. So the refrigerant should be preferably be non-flammable and non-explosive. అర్థమైందా? So why? Because of safety conditions, and also they will be at residential places, at crowded places. The refrigerants what they are using, either inorganic refrigerants or organic refrigerants, whatever. So they have to maintain the flammability. It should not be non-explosive, and it should be inflammable and non-explosive in nature. See here, non-explosive and non-flammable. అంటే అది ఎక్స్ప్లోజ్ అవ్వకూడదు, బాంబు లాగా పేలకూడదు, అట్ ది సేమ్ టైం మంట అంటుకునే గుణము ఉండకూడదు. ఫర్ ఫ్లేమబుల్ రెఫ్రిజరెంట్స్ స్పెషల్ ప్రికాషన్స్ షుడ్ బి టేకెన్ to avoid the accidents. Okay na? So what they are saying, if at all you are having the refrigerants which are flammable type, okay, which are flammable type, so definitely it should we have to take some care, and we have to maintain some precautions in order to avoid the accidents. Got it? Next point, chemical stability. Next point is chemical stability. The refrigerant should be chemically stable as long as they are inside the refrigeration system. What are you saying here? The chemical stability, the refrigerant should be stable as long as possible, so that it will be inside the refrigeration system. It is also the one of the important point for factor of safety. Next, compatibility. What is the meaning of compatibility? With common materials of construction, both metals and non-metals. So coming to the materials of the refrigerant uh, closure, the common materials which they are using should be metals or non-metals. What are the metals? Metals may be cast iron, mild steel, steel, or non-ferrous. Ferrous metals or non-ferrous metals. And what are the non-metals? The non-metals may be high-end rubbers, polymers, it may be the plastic, the composites. So like this we are using the non-metals for this concept. Next, miscibility with lubricating oils. Miscibility with lubricating oils. What is the point here? Miscibility with lubricating oils means oil separators have to be used if the refrigerant is not miscible with lubricating oil, right? Example, ammonia. What it is saying here? Oil separators have to be used if the refrigerant is not miscible with lubricating oil. So what is the example? Ammonia. So it should be oil separators have to be used, right? We have to use separate oils for the mixing of the oil with the lubricating system. Next one, dielectric strength. Next point is dielectric strength. This is an important property for the systems using hermetic compressors. For these systems, the refrigerant should have as high as dielectric strength as possible. Simply చెప్పాలంటే, for refrigerants, in order to go for a good and long efficiency, we have to maintain high dielectric strength, right? We have to maintain high dielectric strength is possible, and it is a good property for this compressors. There is a good point. Next, ease of leak detection. So easily we are having the scope of leak detecting concept. So why? Because so it is a liquid in process. So definitely the chambers or the platforms where you are placing, definitely you have to maintain the leak proofs. Next, in the event of the leakage of the refrigerant from the system, it should be easily detect the leaks. Next, economic properties. What are the economic properties? The refrigerants used should be preferably be inexpensive and easily available. So what it is saying? Economic property. Economic ante amount. Economic means the capital, the money. So whatever the things, whatever you are purchasing, the consumer or the vendor from the distributor, the vendor should provide them. Next point. Next topic is comparison of refrigerants. Comparison of refrigerants. So there is no such refrigerant, means there is no 100% ideal refrigeration. There is no 100% refrigerant in the world. There is no such refrigerant which can be used under all operating conditions. So in the universe, there is no 100% refrigerants which will operate under all operating conditions. The characteristics of some refrigerants make them suitable for those with reciprocating compressors. The characteristics of some refrigerants can be made. So the point here says that the characteristics of some refinement makes us. So what is the meaning of this one? The characteristics of some refrigerants make them suitable for the use of reciprocating compressors, right? So here the ideal refrigerant system which can be used for all operating conditions, but the characteristics of some refrigerants make them suitable for use with reciprocating compressors than that another refrigerants must be more centered. Right? Next. The characteristics of some refrigerants make them suitable for which the reciprocating compressors and their refrigerants are best suited to centrifugally or rotated compressors. Therefore, in order to select a correct refrigerant, what we should require, it is necessary to satisfy those properties which make it ideal to be used for particular application. We should just discuss the thermodynamic, chemical, and physical properties of some important refrigerants. What it is saying, the comparison of refrigerants, there is no such comparison. Only the thing is the body manufacturing. So the material what they are using and the liquid what they are dumping totally will be there, right? Right or wrong? Next. Here the comparison is suitable for the use of reciprocating compressors or other type of compressors, refrigerants which can be suited for centrifugal type of rotary compressors. Here you are having reciprocating type, here you are having the centrifugal type, and here you are having the rotary type. Therefore, in order to select the cool and correct refrigerant, we require sufficient time and those properties which make ideal to be used for the particular application. Got it? Next topic. Chemical properties of refrigerants. So, what are the chemical properties of refrigerants to be discovered? Okay, next. The properties what they have given are, first point is the flammability. Flammability. What is the meaning of flammability? We have already discussed as a refrigerant has a halocarbon refrigerant, halocarbon hydrocarbon refrigerant. So we have discussed about the uh, high carbon high carbon person, right? So we have already discussed about the high hydrocarbon refrigerants such as ethane, propane, etc. for highly flammable. Ammonia is also somewhat flammable and becomes explosive when mixed with air in the ratio of 16 to 25%. The halogen refrigerants are neither flammable nor expensive. So what does this says? This says here. So this says, so they have to involve in the process and it has to be finished. So whatever the discussion that we know, so we have to plan it, right? So finally, what it is saying, The halocarbon refrigerants are neither flammable nor non-explosive. Non-explosive. Ammonia is also somewhat flammable and becomes explosive when mixed with air in the ratio of 60:25. Okay, that is the meaning of the sentence. So the first ethic or the second one is toxicity, right? The second property is a toxicity. The toxicity of refrigerant may be the prime or secondary importance depending upon the application. Some non-toxic refrigerants, such as fluorocarbon refrigerants and toxic refrigerants, so is the concept here, right? The toxicity nature. The following table shows the relative toxicity of the common refrigerants based upon the concentration and exposure time required to produce the serious results. Okay, so here just we have a sample or a table shows that the the toxicity of common refrigerants based upon the concentration, the time exposed to the atmosphere. Next, solubility of water. Third one is a solubility of vapor. Okay, next one. Water is only slightly soluble in R12 at 18 degrees centigrade. It will hold 6 parts per million by weight. Therefore, the solution is very slightly corrosive, and any common metals, the solubility of water may be R21, 22, like that. So within the water is R22 and moving more than 2.2, right? So this is a standards what they are planned, and the solution from very slightly corrosive to any common walls. The solubility of water with R22 is more than R22 by the ratio 3:1. If more water is present, that can be dissolved by the refrigerant. Okay, this may avoided by the this may be avoided by proper dehydration of the refrigerating unit before charging, and maybe use of silica gel for drying the liquid line. So whenever the this refrigerant is passed, so we are having the temperature, we are having uh, what we are having, if water is present can be dissolved with refrigerant, the ice will be formed with the chokes of expansion value. So for this reason, a wetted cloth is put at the point of leak to avoid the harm to persons without working in ammonia refrigerant plants. Okay, so ammonia is a chemical, it is some sort of health condition. These people has been used a wetted cloth to put a leak over, avoid to harm the persons working in ammonia refrigeration plants. So they are seeking with the human value. Next, miscibility. Miscibility means the ability of refrigerant to mix oils is called miscibility, right? The ability of a refrigerant to mix with oil. Okay, to mix with oil. Right? Next one. The degree of miscibility depends upon the temperature of oil and the pressure of refrigerating vapor. So this is the most important. Oil and pressure of refrigerating vapor. So the degree should be depend upon the temperature of the oil, what type of temperature you are maintaining, and the pressure of refrigerating vapor. The freon group of refrigerant are highly miscible refrigerants, while ammonia, carbon dioxide, sulfur dioxide, methyl chloride are relatively non-miscible. So that is the fact, right? Okay, next. Effect on perishable materials. So what it is saying that the effect on perishable materials. What is the meaning of perishable here? The perishable means the materials which will be last for less time. The refrigerants used in cold storage plant and in the domestic refrigerators should be such that in case of leakage, it should have no effect on the perishable materials. The Freon group of refrigerant have no effect upon dairy products, meats, vegetables, flowers, and furs. There will be no change in color, taste, texture, or of materials when exposed to the Freon. So, what is the meaning of Freon? Freon is also a magical. It is also a material. So, where these are used in normal and domestic refrigerators, right? So, the refrigerants used in cold storage is a plant. So these are the storage plant and domestic refrigerators also they are using. It should have no effect on the perishable materials. The Freon group of refrigerants have no effect on. So finally, what is the conclusion of this fifth point? So the domestic refrigerators and small gauging refrigerators we use 100% the perishable things. So we are having excellent closure. Thereby, what happens? It will be healthy and it will not get any suffocation for that. Okay, means the meat, the poultry, the flowers for there will be no change in color, taste, or texture of the mind we explore. Right? There is the effect of perishable material. Next. The next topic to be discussed is secondary refrigerants. So primary refrigerants చెప్పుకున్నాం. Secondary refrigerants we are discussing now. So the brines are known as secondary refrigerants. So what are you saying here? The brines. The brine is a solution. A brine is a secondary refrigerant and are generally used where temperatures are required. The brines are secondary refrigerants and are generally used where temperatures are required to be maintained below the freezing point of water, that is 0 degrees centigrade. So where the brines are used, so finally simply we can say the brines are used for less than 30 degrees in this type. Next point. Okay, so finally the brines are the refrigerants which are used for maintaining the low freezing point. In case of temperature involved is above the freezing point of water, then the water is commonly used as secondary refrigerant. సో ఏదైతే మనకి మోర్ దాన్ వాటర్ బాయిలింగ్ మోర్ దాన్ ద పాయింట్ ఆఫ్ వాటర్ 0 degrees 5 కావాలో దెన్ వీఆర్ యూజింగ్ దెన్ వాటర్ యాజ్ ఎ secondary refrigerant meeting. Next, then what is a brine here? A brine is a solution. A brine is a solution of salt in water. Okay, the brine is a solution of salt in water. It may be noted that when the salt is mixed in water, the freezing temperature of solution becomes as low as that of the water. So this is due to the fact the salt which will dissolve in water takes off its latent heat from the solution and cools below the freezing point. The mass of the salt in the solution expressed as percentage of mass and solution known as concentration. Okay, so here the concentration salt is increased beyond the certain point, then the freezing point increases instead of decreasing, then that type of temperature is minimum, which is known as eutectic temperature, and concentration point is known as eutectic point, right? Eutectic point. The brine used in the particular application should have a concentration for which the freezing point of a brine is 5 degrees centigrade to 8 degrees centigrade rather than that of the brine temperature required. Right? That is a concept of the secondary refrigerant, in that we are having some of the materials where brine is one of the solution of the water, where it is treated, where the brine is treated normally. The brines commonly used in the in the rolling is the brines which are commonly used in the refrigerants are calcium carbide, CaCl2, calcium carbide, sodium chloride, NaCl2, sodium chloride, that is a common salt, that is sodium chloride. Sodium chloride means NaCl, that is common salt. And glycols such as ethyl glycol, polypropylene glycol, etc. So these are the some of the secondary refrigerants in that the brine is a 80% good and 10% wrong, just like a tick. Okay, so these are the secondary refrigerants which are used in the refrigerants where the temperatures are low. See the figure here. The figure shows the special secondary brine. This is the figure. This is the figure, right? Next. If you see the application of various brines, so brine and it is a secondary solution where we are having less temperatures, right? So here a brine solution, see here. So in this we are saying that uh, brine is a secondary solutions and where the temperatures are required to maintain the below the freezing point of water in case of temperature involved here, then the area that it is commonly used in secondary. Secondary. So, what is a brine here? A brine is a mixture of salt in water. Okay, finally, a brine is a mixture of salt in water. The figure shows the special secondary refrigerants. Coming to the applications of these brines, see here where brines are used and where the brines are used and what which brines are using in the market globally. See here for breweries. Breweries means beer manufacturing, alcohol manufacturing, or cool drink manufacturing unit. What type of brine is used? We use polypropylene, right? So for breweries, we are using polyphenyl glycol. Then what is the second one? Chemical plants. So in the chemical plants, what type of things we are using? In the chemical plants, we are using the sodium chloride, calcium chloride, and ethylene glycol. For the huge chemical plants, we are using brine such as sodium chloride, calcium chloride, and ethylene glycol. Next, dairy. Dairy means milk. So in the dairy system, we are using sodium chloride, calcium chloride, and polypropylene glycol. Next, coming to the food processing, we are using sodium chloride, calcium chloride, polypropylene gold. Next, ice creams. For the ice creams, what we are using calcium carbide. We are using calcium carbide and polypropylene glycol. Next, coming to the ice plant factory, we are using sodium chloride. Next, meat packing system. For a meat packing system, we require heavy cooling of the air conditioning. So that sodium chloride and calcium chloride we are used, right? Next, the skating ring. For the skating ring, calculate the chloride. So for the special low temperature, the calcium chloride and ethyl glycol. So these are the important these are the important brines which are used for organic refrigerants or inorganic refrigerants. So whenever you are using for inorganic refrigerants and inside, so we have to maintain proper ventilation without any damage. Got it? So these are the various types of brines what we are using in the factory and other factories. Okay, got it? See the applications one time, where the brines are used and what is the name of the brine we are using in particular areas. See the first one is breweries, beer manufacturing or liquor manufacturing, and the chemical plants and the milk dairies and the food processing units and ice cream units and ice fat units and meat packing place, that is a skating ring place, and the spatial low turmeric, spatial low temperature. So for small and least temperatures, we are using calcium chloride and ethanol glycol. So these are the applications where brine is used whenever it is fitted to the air conditioning system. Got it? Next, right? See here. So the mass of the salt in the solution, what we are saying, the brine is nothing but the mixture of salt and water, salt in water. Okay, it may be noted that when the salt is mixed in water, then the freezing temperature of a solution becomes lower than that of the water. So keep in mind this point. The freezing temperature of a water manaku okati unte, but when salt is mixed in water, then automatically the freezing point of the water will be changed because the salt while dissolving in water, what it takes off the latent heat. అర్థమైందా? సో నార్మల్ వాటర్ కంటే ఎప్పుడైతే సాల్ట్ ఈస్ మిక్స్డ్ ఇన్ వాటర్, then we are observing for the solution, right? So absolutely the salt with is mixed with water having lower temperature than that of the water. So because of that, when the salt is dissolved in water, it takes a latent heat outside the body. The mass of the salt in the solution, right? See here, below the below the freezing point of the water, the mass of the salt in the solution expressed as a percentage of the mass of the solution known as concentration. So in a salt water, when the salt is present as in a lump, as in a solid form, percentage in the mass is expressed as a concentration. Now as the concentration of the solution increases, the freezing point decreases. So ఎప్పుడైతే the salt content increase అయ్యే కొద్ది concentration will changes automatically, the solution increases, the freezing point decreases. But if the concentration of the salt is increased beyond the certain point, the freezing point increases instead of decreasing. The point which is the freezing temperature is minimum, then it is known as eutectic temperature, and the concentration at this point is known as eutectic concentration. Got it? So like this we have to process, particularly you have to understand the concept of brine solution, where you are having generally water or the salt is mixed with water. So the brines commonly used is calcium carbide, calcium chloride, right? Calcium glycerol, ethylene glycerol, propylene glycerol. So these are the main examples of the brine solution. Got understood? Now if you see the designation of a refrigerant here, an example, what it is saying that if you want to know the R11 ఎలా వచ్చింది, R114 ఎలా వచ్చిందో, so we have to an example what we can discuss now. And also if you see R పక్కన 2 digits చూసారంటే it is nothing but ethane based, and if it is a 3 digit number it is a ethane based, right? Two numbers ఉంటాయి METHANE methane. When there are three numbers it is ETHANE methane, right? And how you are getting the designation letters means if we take the chemical, the general chemical formula where n plus p plus q is equals to 2m plus 2. So we have to find the values of m n p q, right? So if you see the example, simply see the example for a dichloromethane. We see that this refrigerant has number of chlorine atoms is equal to p is equal to 2, and the number of fluorine atoms q is equals to 2. One second. The number of the number of chlorine atoms, p is equals to 2, and the number of fluorine atoms q is equals to 2. Then what are the hydrogen number of hydrogen atoms? N is equals to 0. Therefore we know that n plus p plus q is equals to 2m plus 2. So పైన values దీంట్లో substitute చేయండి. So whenever you are substituting the upper values here, 0 plus 2 plus, we are getting 0 plus 2 plus 2. Then what's the meaning? Total 4 is equals to 2m plus 2. 2 2's, therefore 2 is equals to 2m, m is equals to 1. Therefore the number of carbon atoms is equals to 1. Then the chemical formula for dichlorochloromethane is see the value CCF2F2, and the number of refrigerants becomes R01 అంటే ముందు దానికి వాల్యూ లేదు కాబట్టి finally we are saying that R12 is a refrigerant for the above said application. Got it? So with this we'll stop the class here, and we'll continue the class in the next session with the other new topic. So till here, if you have any doubts, please let me know. So as the time is ending here, we'll stop the class. Got it? Now we'll stop this class here. Tomorrow in the class we'll discuss about some of the other topics related to the brine and the VCR components and some of the VCR systems. Got it? So we'll stop the class here. We'll switch on to the tomorrow's class.